why is on flock 3 it's 2.7?
Yes.
Why is that again?
Well,
That's the average.
and why is it the average? Good. Thank you, Ryan. Why is it the average?
It like. Let me backtrack.
Go, backtrack.
Like, well, like, okay. I'm trying to put this.
You got it. You got it.
Because when we did flock number 1, flock number 2, we added all like 0 times 0.01
Good.
plus 1 times 0.18 plus 2 times 0.81. We did that for if we did that for flock number 3, we get 2.7.
Exactly. So that's a beautiful mathematical answer. I loved it, Ryan. So
Okay.
so if you do 3 times 0.729, that's about 2.1-ish. Then 2 times 0.24, that's about 0.5-ish. Add that in. 1 times 0.027 doesn't contribute hardly anything, and 0 times 0.01 doesn't contribute anything. If you add all that together, you get about you get exactly 2.7.
Got it.
That's one way of thinking that. I love that. That'll always work mathematically for any situation. Another way that you could think of it is how?
Adding just 0.9 to each time.
Every time you add a bird to your flock, you're adding 0.9 of a girl.
Because you've already figured out your initial average is 0.9 for one bird.
0.9 girls per one bird. So it's 1.8
For 2.
girls for 2, 2.7 girls for 3, and therefore, we now know on average how many I'm going to get in my flock. 3.6. So every time you add a bird, you're going to add 0.9 of a girl. So flock number 4, we're going to buy 4 of those pullets, and we already know the average is 3.6 girls per 4 birds. And I think it was so important to hear you say that, had that per in there. Ryan, I love your answer because your answer gives us a workable solution every single time. The problem with doing it our way is how often are you going to, a Gallup poll, for example, usually polls around 2,000 people. Are you going to start by polling one person, then poll 2, and then calculate a distribution every time? God, no, you're not. You're going to go straight to 2,000 and build a distribution around 2,000. But in order to do that, we have to see the pieces of the distribution that we're starting to see right now. So thank you for giving us the overriding solution.
But in all fairness, we're doing your 4 pullets. In all fairness.
But there's a way to get right to this flock without going 1, 2, and 3 first.
But,
It's
we're just doing it with your.
Actually, you're doing it for any distribution where there are 4 elements and a 90% chance of it happening. And
I'm
believe
just,
it or
saying,
not,
I'm just saying in particular, we're just doing.
you sound pissed at me now.
I'm not finished.
Okay, I'm sorry. It's not accusatory. Doing your flock, damn it. But yeah, you're right. We are looking at our flock right now. You're 100% correct. Cool?
I'm just saying in all
It's all
fairness.
good. It's all good. So, how many girls can I have?
0,
Might not have any.
1,
Might have 1.
2,
Might have 2.
3.
Might have 3.
4.
Love it. Let's build them. Follow the patterns. We've already established. Follow the patterns.
For 0 is 0.1 to 45.
Buying that? 0 is always going to be whatever the complement of 0.9 is to however many there are patterns. So it's 1 in 10,000. That's not going to happen, except for 1 in 10,000 trials. Which, as you might recall, is the same probability of getting one of those double-sexed chicks, 1 in 10,000.
Let's go down.
Well, go straight down?
Yeah.
Good! Want to go straight to this one now?
No. Let's go to the 4th one.
Oh, you're going to go to the 4th one. I agree. That's the next easiest one to get, isn't it? This is like Snake Eyes. This is boxcars. You already know this one. We did this one already earlier today, didn't we? We did this one. That was the first argument we did for independent versus dependent sampling, remember? It was 0.9 to the 4th power. It was the very first thing we did on the computers today, yes? Yeah. And what did that end up being? If my memory serves me, I think it was 6561, I think. Well, I wouldn't give it too much credit. It's just that I happened to look at it as I walked by. That was about 30 seconds ago. 10 more seconds, go on. Where do we go next? Monica?
So for the 1, it would be 4 times the 0.9 times 0.1 times 0.1 times 0.1.
You guys hear this?
Count for the 4.
Oh, I love that. So Mike's saying for the 1, that means I have to get 1 girl and 3 boys. So I've got to get a 0.9, and if it's okay with you guys, I'm going to go 0.1 cubed.
Yes.
Just to save us the writing. Now, that's not enough because Monica said we have to identify the 4 boys. Where are they?
They're, well, they could
Where's the boy? They could be...
there.
Or. I love the word or. I love hearing you guys say that. And I know you're thinking it. Either Bertha's the boy, or Marge, or Nancy, or there's Mary up there. She's the little velociraptor who bites my butt. Cool? So there's 4 possibilities. I want to put that in a different color because that is an important little number. 4 right there. I have a whole quiz devoted to these numbers because there's beautiful mathematics even behind those numbers and how to calculate them. So the quiz for next week you'll see, it's called the combination of Pascal's triangle. We'll come back to that. And what's this? It's kind of fun, I think. Let me see if I get the number of zeros right. 0.036?
Yeah.
Is that right? Did I get that right? Thank you. So that should not happen. That's going to happen in 36 out of 10,000 trials. That should not happen very often, right? I would call that an outlier, yes? We call that an outlier. All right. You want to jump down and do 3 now? Oh, Haley, go ahead.
Okay, so is it 0.9 squared plus 0.1 squared?
Oh, good. So you're going here. This would be 0.9 squared times 0.1 squared.
Yeah.
Times 4.
That's my question.
Can we come back to this one, if you would? Let's come, if you don't mind. I want to skip this one. I want to go straight to this one, because this one actually mirrors 1 pretty well. Good. Kelsey's like, yeah, do that one. These two mirror each other pretty well, and these two mirror each other. Just like on 3, 0 and 3 mirrored 1 and 2. As you work your way in, they mirror. Let's hold that thought for the 2 for just a second, Haley.
Yeah.
Let's go 0.9 cubed, 0.1 to the first, right? Because you got 3 girls and a boy. But how many ways can that happen?
Times 4.
That's still 4, isn't it? Joseph's like, I buy that, I buy that. Because if you have 3 girls and a boy, where can the 3 girls be? Well, it might be these girls, these girls, these girls, or these girls. There's only 3. Or, easier, find the rooster. Which one's the rooster? It's either Bertha, or Marge, or Nancy, or Mary. Do you see how it doesn't matter which you count, whether you count the roosters or the chickens? Because if you've identified the roosters, by default, you've identified the chickens because it's whatever's left.
You kind of go up and down. So from the bottom, you're going 4, 3, 2, 1.
Hang on now, from a
4,
marker.
3, 2.
Right, there it is. So this is 4, yes?
Right.
So what's that going to be? 0.729,
0.29.
0.07, about 28%. Oh, what do you got, Carly?
2916.
2916. Ooh, look how common that is. That's 29% of the time you're going to get a boy in there. That's roughly 1 in 3, isn't it? Ish. Well, it's 3 in 10, but I got 3 in 10. So if I said max in to buy birds 10 times, you can expect that about 3 of those 10 times we're going to get one rooster in those boxes. And that makes perfect sense. You should. You keep buying these birds, you're going to get a rooster eventually. That's what that 0.9 stands for. You guys buying that logic? It's like playing craps. You're eventually going to lose. You have a whole quiz for next week devoted to the gambler's room, which is a guaranteed way to make $1 by playing craps. Just keep betting. It might take you $5 million to earn 1, but you will win your $1 eventually if you don't bankrupt yourself. The problem is you'll bankrupt yourself first. But anyway, that's the point of probability. It said it will always win. It always wins. Now the question, of course, is what goes right here.
6. 6.
Why 6?
Because there's 6 ways to get to 2.
Let's count them. You guys have already counted them, I say.
Yeah.
We need 2 girls. Here we go. Count with me.
1, 2, 3, 4, 5,
6.
6.
Great.
They are. I didn't miss any, right?
No.
We didn't miss any. It's 6. It's 6. They're beautiful. Now, again, you can check to make sure that's right, can't you? You can check to make sure that's right by simply multiplying it out. That's 0.80081 times 6. That's about 5%, I think. Check my math on this one. Check my math on that.
Yep.
486? Good. Good. That's small enough for me to do in my head. Not guaranteed accuracy. That's why you guys are checking me on this. Does it sum to 100%? That n sums to 0. That makes me happy. David saying yes, it does? Good. Ask me that question, Carly.
Okay. So it's really easy to find that it's 6 when we're looking at pictures of 4. So if we have 200,000, I'm not
Yes.
going to look at 200,000.
Holy crap. So here's a fantastic question. Go ahead.
So
Let's hear it.
when we only have 4, you could get 6 by adding 3 plus 2 plus 1.
You could.
Or you could get n minus 1
Cool. This is you.
exclamation. So my question is, which one is the way to do it? Because it's gonna with
Neither.
4, it's gonna be they're gonna be 2 different numbers.
Neither is the way to, neither the way you just described is the most efficient way.
Okay.
And I love what you did. So can I answer your question in a little more detail?
Yeah.
Now this is hinting toward a quiz you might choose or choose not to do next week. The coefficients that were in our distributions are indicated in this little graphic right here. You might recognize some. 1, if you put 1s here. 14641 is that bottom row right there.
Right.
1331 was over here. 1331. 1, 2. We didn't write the 2 here, but there is a 2 implied there, isn't there? Because there are 2 of them. 1, 2, 1. And then the previous one, which I've now erased, had 2 1s. If you arrange them like this, this is a foolproof but very, very cumbersome way of figuring out what you need. So Carly asked a question. What if you got 200,000 chickens? You're Frank Perdue. What if you got 200,000 chickens? Well, this will actually get you the results. You can get the numbers you need from the next row. You always start with 1, which hopefully makes sense. You just multiply a bunch of point ones together. The next number you need is found by adding these 2 together. 1 plus 4 is 5. See? 1 plus 3 is 4. Plus 2 is 3, and so forth and so on. This one is found by adding these 2 together. 10. 3 plus 3 was 6. Yes? 6 plus 4 is 10. 4 plus 1 is 5, and then it ends with a 1. So if once you multiply all the 0.9s and 0.1s together, those are the numbers you need in the next row. Marty's face just fell ashen. Because I will never expect you to do that. Because if you had to get down even to a number like 20 chickens, that means you'd have to have row 19, which means you'd have to row 18, which means you'd have to have 17, 16, back to essentially 2 and 1, and back to the beginning.
Isn't that what you had as kind of similar to in 105? though?
Very similar to this, extraordinarily similar to this, yes. But we didn't get that far. We didn't get as far as I would have hoped we would have gotten into it. But yeah, we did hint upon this. So Carly, that's not the way I want you to do it. It's called Pascal's triangle. It's freaking gorgeous, and I put a whole quiz out there next week if you're interested in it. You might not be. You might take one look and be like, no, don't. That's totally fine. So the question is, how do you then do it? Well, here's 2 answers for you. And you hinted upon one of them, what you just said earlier, the n-1. One way, when you look at your projects that are due Thursday, is you can look at the permutations versus combinations bit, which is a little small part of that project. These are actually called combinations. If you have a combination and you take 4 birds and you want 2 of them to be girls, 4 choose 2 is equal to 6 mathematically. And your project shows you how to do that should you want to do that. I don't want you to do it that way, because then this becomes formulaic. This becomes formulaic and we lose the forest for the trees. Here's how I want you to do it. With your permission, I think this works better, because this allows us to focus on the forest and not just the trees that make up the forest. Now here's what I want you to do. You don't have this yet. I'm going to share it with, we're going to break class earlier today, and I'm going to share this with you so you have it. You don't have this program yet, but I wrote a program called dist fill, which I have to unarchive. Hang on one second. I don't understand why I have to do this, but I do. Here we go. So I'll share this with you after class today. We'll take 5 and we'll hook you all up. If you run dist fill, it asks you to build a distribution. So I asked for smallest x. Let's suppose we're building my chicken flock. So the smallest x would be 0 for 0 girls. The largest x would be 4 for 4 girls. At this point, it has filled L1 with 0, 1, 2, 3, and 4, just like we did here. Then it asks you, what do you want to do? Binomial, uniform, PDF, or manual? We're going to get to binomial. This is a binomial. Now, I didn't define that yet for you guys, but think about why. We'll save the definition for next time, watching the clock. Binomial. Why do you think it's called that?
There are 2 options.
2 options. It's either a boy or it's a girl when you grab it. Remember I said earlier it's technically trinomial if you account for that 1 in 10,000. That was trinomial. We're ignoring that because that doesn't change very much. This is a binomial. I want to start class on Thursday with a more formal definition of binomial. So we're going to pick binomial. It then asks you, okay, if it's binomial, there's a probability, right? And you're interested in getting girls. What was that probability?
0.9.
0.9. You put in 0.9, 90%. Thank you. Make sure you put it in as 0.9 as a decimal. That's why I've got it set up. When you press enter, it thinks a little bit and it says done. Now, done, you're like, okay, it's done, great. When you go to stat edit, you now have your distribution right there in L1 and L2. I'm going to clear this out because that's from 244 from yesterday. There's your distribution right there. That's what we just built over the past 10 minutes.
What's the E?
Scientific notation.
Yeah.
10 to the negative 4th power. 0.0001. It's the same as this. Written in scientific notation.
So it
0.0001.
says something on the project that says don't use E.
Don't, because because of the fact you just asked that question. If you use it without knowing what it stands for, That's awful.
Move the decimal point.
Move the decimal point 4 spaces that way. So if it's 1.0, it's
Now adding.
0.0001. Fair? Carly?
Well, that doesn't really answer my question.
Sure it does.
So,
How do I expect you to do it? That's how I expect you to do it.
But you're gonna give
that
us a
wasn't
formula.
exactly my question, but that's okay.
Go ahead. Give me your question again then.
If I had a population of 200,000.
Yes.
And I wanted to know a certain combination, and I didn't have access to your program.
Yes.
How would I mathematically find?
It's in
would
your
I have
project.
to do-
It's mentioned, like I said, it's in your project. It's a combination, and it's,
Okay.
Haley, you use that word, combination. It's in your
Alright.
project. If you want it mathematically, by all means, use the formula that's in your project.
Okay.
But I slid that aside because that's not the most efficient way of doing it.
Okay.
As a matter of fact, I'll never forget this. David Moore, he's a textbook author. He was actually quoted as saying, sure, we can make students memorize the formulas and use things like combinations, or we can use software, get the results, then average the results. But in his textbooks, he keeps printing the formulas. So I'm hoping that some chance someday I get to meet the guy and be like, so, you say one thing, but you profit off another. I'm interested in that. That's the answer to your question, but the answer to your question is too mathematical and not statistical enough.
Okay.
The statistical answer is the 4 and the 6 are already taken care of here. Watch this, watch this. Let's make a flock of 22 birds. 22 birds, okay? So back to the program. I'm going to give this to you.
Really quick.
Oh,
Why
Kels.
does it put a bunch of 9s after it?
Why does it put a
Like,
bunch of
when you
9s?
scroll up, sorry.
That's okay, I'll go back to it.
Yeah.
Oh, it's approximating to 100 decimals, and for whatever reason, it doesn't like the exact form. I don't know. If you look, and to answer your question again, Carly, if you look at the code for my program, which I don't really encourage you to do all that much because it's easy to screw it up once you get in there. If you scroll down, you'll eventually see there's the binomial cube right there. That is the function that the TI has built in that does those combinations for you. But it becomes gibberish. Only the TI uses this language. So I'd rather not teach you that. I'd rather show you a piece of software that's pretty much universal and have you interpret the results. See now, because watch this. Once you have that distribution in your stat editor, you can then run one bar stats on L1 and L2, and there's your average of 3.6 up there. Same as we calculated, but we didn't have to go flock 1, 2, and 3 to get to flock 4. Fair? Now, Carly, your question's great. Totally great. It's just that I don't want you getting hung up in that calculation. I want you getting hung up in, not at all actually, I want you getting the results and then being able to interpret those results. That's what I've noticed in the 20 years of teaching this course. Students get buried in the formulas and they lose track of what they're even trying to do. The 1/3 thing that I used with that gentleman on the, it's right here. I mean, that's all I had to do. But students get lost. They don't even realize how to look at that piece of the distribution. This gets you the distribution and allows you the time to then think about it. Fair? Decent. If you want more mathematics, it's in the project waiting for you if you want more mathematics. Absolutely. I don't want to deny you that if you want it. But this is way more useful statistics-wise. Good? Very good point. Let's break about 5 minutes early right now. I've got a whole bunch of programs I want to share with you guys. We'll show you how to use it more next time. Obviously, I'm going to give it to you right now, but we're going to break it in about 5-6 minutes. Let's spread it around. I got to plug in one machine at a time. Does anybody know how to link programs in here? Does anybody know how to share programs with the TI? Maybe I can teach somebody real quick. We can speed the process
I've
up.
done it before.
You have? Let me reteach you real quick, if you don't mind, Carly. And that way, I'll give you yours first.